Okay. Is this working? I'm not sure. It's probably working. Anyway. So they will erase one of the lines from both ends simultaneously. A second. So here wants to choose a line so that together the cylinder they erase for it as long as possible. Maximum time. Okay. Just need to find the maximum consecutive. Like we have 5, so take 3. Got it. So this will be screen. Hash plus C else. Oh, that's wrong. Right, we just need to do this. Okay. The arrangement is called need if in every stack except the rightmost one. Okay, except the last one. The number of books strictly less than the stack in its right. Strictly less than. That means it's okay. That is the array is strictly increasing. Okay. Euro one wants to make the arrangement need by performing the following option. Choose a stack I such that it's not the last and it's greater. Take one book from this stack, AI decrease by 1, and put it into the next stack, and this increase by 2. Determine whether I can make it neat or not. So we just need to make it strictly increasing. So when it's not possible, for this case, it's not possible because this one on. So if there is one on, then it's not. So I think maybe we'll just do it greedily, right? So we have this. We have a of 0 minus 1, right? Yeah, it's not, yeah, at least 1. So like a of 0 is 1. Now if okay, like I want to make it 2, so if a of I is greater than I plus 1, then have plus is equal I plus 1 will be minus a of I, else a of I plus is equal basically like half of I, half minus is equal a of I minus, this is different. If at any point our half become less than 0, then it's never possible. I will return no, otherwise it's yes. So yes, no, yes, yes, no, yes. I think it's correct. Let's go to problem C. So Stephen found a permutation P of length n. Of course, he decided to sort it to make it make the process more interesting. He chooses two positive integers x and y, such that it's less than equal to n. Okay, and define a rule for swapping elements. In on-move, Stephen can choose to initialize and swap the element this if at least one of the following conditions are met. Okay, there the index difference must be either x or 0. Stephen wants to know if it is possible to sort the permutation using any number of such a operation. Okay, xy is already given, right? Xy is already given, so two, right? And okay, I think if z is equal to 1, then it's always possible. Otherwise, we need to do something like, we need to do it quickly. So sort the permutation. Since it is a permutation, so each of the elements is unique. We know how to like what to do. So first of all, we need 1 here. Now, like okay, let's try this test case. We need 1 at this position, so we have either 2 or 3. Difference of them must be 2 or 3. So if we swap 1 here and then here, we can definitely do it. Yeah, so you can swap any indices who are the multiple of x or multiple of y. So maybe we can first swap those two positions, I think, right? And then you can also probably swap but there is a simple number theory here, like if LCM of xy, let's say k, so we have this position k by which we can definitely swap any elements. For example, for 2, 3 we can swap 1 3 5, and then you can swap 2 4 6, 6, and then we can swap 3 5 again. It will then on by 3 we can swap 1 4 and 7, and then you can swap 2 5 8. So that means I think we can use a DSU here, like the common positions where we can swap. Let's do it again, I think. Let's use a DSU. So so it's like we can start from x and go up to n, and then we can say that DSU I minus x is I minus 1, right? And at the same time we can do it for y, right? Yeah, so then we can find sets. Like I'll just do it quickly. So this is your set. Maybe like a map of vector is quite easy. So m of d dot find of I dot push back of I, or maybe just I. Then so after that we'll just do this. Sort p dot rd p dot, then we just do this. A of I is equal m of t dot find of I dot back find of I of back. Now we'll just see if we sort it. Well, okay, then yes, otherwise no. I think I just made it complicated. Yes. Okay. Let's check this second space. 2 right. So we are merging 0, 3, 1, 4 and 2, 5, and here we are merging 0, 1. No, it's not 1, 2. Okay, I have an issue here. I'm supposed to do is this. F of x. So f of not sure where is the issue. X plus y is less than x, so definitely that is y. Okay. So first I just want to see this. Right. If it's okay after this, no. Okay. So z equal to is the f of I dot psi. Then what we are doing, like f of I of say what is the f of oh, sorry, right, it should be f I. Okay, finally it's now straightforward. This took me a huge time. Okay, Euroslav's productivity during the day is described by an array of length, and his productivity can be negative if he watches short videos or positive if he works. The total productivity is defined as the sum of all values in the array. Sometime Yaroslav reads motivational posts. He has M post where Z post has an impact value Bj. he has m post where zth post has an impact value bj. If Euroslav reads a post with value bj, then all productivity values from the beginning of the day up to position bj change sign, that is all integer a1 to a bj are multiplied by -1. For example, let Euroslav reads a post with value 3, then the sign of the first 3 elements are flipped and the array becomes this. If he then reads a post with value this, what is the maximum possible total productivity value Euroslav can achieve by reading any possible of the posts? So can achieve by reading any of the posts. In the first instance, they're saying that the answer is 3. Like, I have this one confusion. Can he just read this in any possible ways? Any of the posts? Any of the posts. Okay, got it this time. So let's try this test case. So he can like read he can just flip the first element sign or the first 5 element signs or even first 3 element sign. So if you flip the last elements sign, like if we just sort them, okay, sort them like 5 will be in the last. So he cannot flip the post 4 or 3. So it's like we are kind of determining what is the maximum possible value from 4, 5, again 4, 5, and then 1, 2, 2, 3, and 1. So for 4, 5, it's definitely better to keep 5 plus and this one. So 1 and then 2 and then 3. So the answer is 3. So I think it is easy. So we have m in the beginning. So we are also taking values of b. Then obviously sort b. Or all of them are distinct, right? Or we basically don't need to sort. So then what is my pointer is equal 0. Obviously for all x of b, so like if like IDs, so while like b dot back is still less than or equal ptr, we'll just do this IDs dot pushback ptr minus minus and then b dot pop back, right? Right. So b dot pushback. Wait. No. No, wait. I'm wrong. We'll do it in reverse. So currently I am at position 1, now at 0. Now it's okay. So for all the IDs, so also here we keep the answer. We keep the answer and like option 1, option 2, IT of IDs, option 1 like plus is equal B of like A of I, option 2 is plus minus is equal A of I. So answer definitely plus max of option 1 from option 2, and in the last we have PTR and I less than M. Three, 4, 5, 6. I think I'm correct. So, right. Yes. So now EFC. Let's go for problem E. So Masha has a New Year garland consisting of n bulbs. Each bulb can be either on or off. Okay. So the state of the garland is given by binary string of length n where 0 is this means the bulb is off, otherwise it's 1. So Masha is considered. Masha is. Wait, is it working? I am not sure. So Masha considered the garland beautiful if the state of the adjacent bulbs strictly alternate. That is, there is no two adjacent bulbs that are both on or off. For example, the garland 0 1 0 1 0 and 1 0 1 0 are beautiful, while 0 1 1 0 and 0 0 0 are not. Here you can apply the following operation to the garland, choose a subsegment and flip the state of all bulbs in it. That is, turn on all the bulbs on or off. Masha invites him to play the following games q times. She chooses a segment from L to R. Bulbs inclusive, and you must make the segment beautiful using atmosphere operation. However, Ura is not sure about is this always possible. So he asks you to determine whether for each game whether he can make the chosen segment beautiful using no more than k operations. K are independent. The garland itself is not actually modified. So you have n and q, 20 over 5 and 0. Okay. So choose a subsegment and flip the state of all bulbs. Every time we are given L, R, and K. For this, we are saying it is possible. Number 5 is the on version. Yeah, it's possible. We can just flip this too. And if it is possible by on version, then definitely it's possible by 2 version. And 2 4. From 2 3 4 it's also possible by on version. And then 1 2 using 0% definitely possible. 3 4 using 0% is not possible. And then here 1 4 it's already good. 2 3 is already good. So all of the test cases are very simple. Let's try different kinds of test case. For example, we have 0 like 1 on 0 0 1. How many operation we need? For example, we want to make 0 1 0 1 0 1 this. Now this is not good, so we must do an operation, and this is good, so we need one operation here. So 1 0 0 1, and then this is good, and we need to make good this. So we need 2 operations. We need 2 operations. Is it possible to do it in less than 2 operation? No. But if we want to make them the string like 1 0 1 0 1, then like it's take 2 operations. But if you want to make this, then it's take 1 operations, because we can just modify this after this. Now let it go. So So it's kind of, we need to just find the number of subsegments which we need to change. Not only number of subsegments. Like for example, we need this to be changed, and this to be changed, and this to be changed. If we do all the operations here, then still we need two operations. So it's better to do them individually, right? Yeah. So we just need to find. We just need to find number of subsegments, number of where we need to do operations. How to do that? How can we find that? How can we find that, right? Can we use segment tree? So let's say, yeah, 0 1 0 1 0 1 or 1 0 1 0 1 0, right? We just need to go through this two type of whether we need to change or not. So you can just go through these two types of pattern, or like the alternating valid sequence which we want to make, and for each of them we can count number of such number of starting or maybe ending and length, ending and length. Yep. Number of positions where it's end. Like what I'm meaning is that so this is string t1 and t2. So if in1, then t1 is plus is equal 0 and t2 plus is equal 1, else t1 plus is equal 1, 0. Pause p1 p2. Where we basically start, right? So are same length and same, right? So if s of I equal t1 of I, then if L on is greater than 0, then t1 dot push back I minus 1, because at that point we end and not 1 probably. Do something with else L on possible 1. Or maybe you can just do this, right? If s of I is not is equal t1 of I, if s of I is not is equal L2, if I equal minus 1 or this, no wait, let's keep things simple. So this will be T2, L2 and P2. If L on is greater than 0, then P1 dot push back they are not similar, so we must like s of I equal t1 of I. If they are equal, then we do this, else p push back. So if so first of all, rents, right? Rents LR 1, 2. If this is 2, then I just make it P2, right? Right. We need to do something as well. last one dot pushback I gonna conc mail on last round dot pushback I think we do not need it. We can just kind of so if like r equal n minus 1, if r is equal n minus 1, no, if r is not equal n minus 1, if r is not equal n minus 1, and then s of r is equal t1 of r, this not is equal, and s of r plus 1 is not equal t on of r plus 1, then ret plus equal 1, return ret. I think this is one liner, so I can just do this. T2 of r and okay, let's test it. No, yes, yes, no, yes. Okay, let's just try the first one first. Debug T on T2. Fine. Then P on P2. T1 is P1, T2 is P2. Okay, so it ends here at 0. That's true. And this ends at 4. This is here. Right, and is this one. Ends it there. That's true. So debug LRK. Or maybe this is the first one. Oh, I'm not taking input of k. That's weird. Yes, no. Okay, now the testing part. I need to test with a very hard test case. For example, we have 1 1 0 1 0 1 0 maybe, or let's say 0 1 1 0 1 on 0 1 on. How many operation in it? 1 0 1 0 1 0 1. Let's try this. So right, maybe 2. Let's see. Yes. Where's P and P2? Only 1 and 7. And P2 is only 4. T2. Yes, P2. Okay, we have 0 on is fine. Then 1 0. This is wrong, right? Or no? It's wrong, I think. So up till this. And another point, 0 3 4, that's true. And the last, it's not giving the last. There should be another one. Oh, I didn't give the answer. Now that looks correct. This is submit. Also, I need another test. Let's see. Many people solve it quickly. Let's try the problem F now. And I elapsed trace. So and I consider root tree with vertex at 1. I like tree problems. For every vertex, its children are ordered from left to right in increasing order of their indices. Wait. Each leaf contains exactly one number from 1 to k. For every vertex, its children are ordered from left to right in increasing order of their indices. Okay. And I notice that if we list the leaves from left to right, their values form a sequence. She wants this sequence to become strictly increasing. To achieve this, and I can perform the following operation. Choose exactly 2 vertices and cyclic shift its children to the left. For example, if a vertex has in order 1 to 3, after the shift, the order becomes 2, 3, 1. The operation can be applied to any vertices any number of times. A visual example of a cyclic shift of these children of vertex 1. So they shift, they do a cyclic shift to 2, 3, 5, and it becomes 3, 5, 2. So the order of the leaves also changed. Strictly okay. So Eura determined whether I can make the sequence of integers in the leaves strictly increasing from left to right using the operation. I want to make it strictly increasing. I think I can visualize this though. I need exclude row. So for the first test case, which is definitely possible. For the second test case, we have 2 to 1 or like 1 to 2. So 1 to 1 to 2. Oh, it's horrible. No, I need to use pen and paper because doing this in using mouse is really a problem. Okay. So for the first test case, it is definitely there. In second discuss we have the vertex from root to root 1 to 2, and then 3 4 is rooted at 2, and for 3 4 we have the value 2 1. Now it is not yet sorted, but we can do a cyclic shift in 3 4 to make them sorted. Yeah. We just need to determine that whether it is possible or not. For the last discus it is not possible. Okay, for the third discus we have 1 to 5, sorry, no, 2 to 5, 2 going to 5, or 5 is the parent of 2, right? 5 to 2, and then also 3, then 4 is the parent of 2, then 5 is the parent of 1. Okay, now we have 3 4, 3 has value 1, 4 has value 2. Initially it is not increasing, but we can make them increasing by just doing a cyclic shift at 5 basically. In the last discuss, let's say everyone is rooted at 1, so 1 2 3 and 4, and we have 2 1 3, 2 1 3, and definitely it's not possible to make them sorted. Interesting problem. I think we'll just come from root to leaf to root and check whether we can sort the child of a particular node. So if you can sort a child of a particular node, or probably we need to keep track of min max. Let's start working on it. Like, I feel like that we have n, and then we have p. So g of p dot pushback I. So the children must be in the order of the input. And then we have values. Definitely the values will be ranged from can they be n? I don't think that they can be n, because all of them cannot be leaf. So they said that the leaves of the tree contain integer from 1 to k, where k is the number of leaves. Each leaves contain exactly 1 numbers, so it cannot be n, right? Because there can be n minus 1 leaves, so if we start from 1 there, that goes up to n minus 1. I don't know why they give up to n. Alright. Bool can is equal, let's say, true. Now we just do a DFS. What? So it will probably return a pair. If cannot, then we'll just return, because we do not need to do anything. Otherwise we what? Push back. Now if vals dot empty, then we'll read then the a of node cannot be equal 0, and it will return a of node comma a of node. Otherwise how to determine that if we cyclic shift wait like we have pair of values. Now we just want to know if we cyclic shift these pairs, can we sort the pairs in increasing order, where each of li will be getter is equal r of I minus 1. Yeah, I have an idea. So So if vals of I minus 1 dot second is less than vals of I dot first, then this is good. Good of I is equal to 1. Else good of I else no. We don't need to consider anything else. So it's like cons is equal to max of cons comma c. So if cons is less than m, then can is equal to false. I think it is okay. It's working. Should I submit or test? Should I submit or test? Submit. I do not want to get any wrong answer, so probably we'll just check. But making a test case for this problem is kind of hard. So you can make a test case like this. So this will be 2 and this will be 5. 5, right? Then this can be any order. 1, 2, 3, 8. This can be any. It's 1. It's a 3 and this 4. It's possible, right? this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the discus will be 1 discus, 9 nodes, and then for 2 it's 1, for 3 it's 1, and for 4 it's 3, for 5 it's 3, for 6 it's 1, for 7 it's 1, for 8 it is 1, 9 it's 3, and the values are like 0, 5, 0, 0, 0, and 3, 1, 4, 2, and for this discus the answer should be no. Right, but if we just switch 3 to 2, this is 2 and this is 3, then it should be yes. Okay, then this is a problem. Right. 2, 3 is 1, 4, 5 is 3, 6, 7 is 4, 8 is 5, 9 is 3. For 9 the value is 9, 8, is 5, the value is 5. 2 is 5. So you can switch this 5 to this side, and then one here, 2 here. Alright, if it is 2, if this is 2 and this is 3, 9 is 3, right? Now 9 is 3, 6 is 2. So 1, 2, then 3, 4, 5. Yeah, it is possible. Wait. I'm not doing cyclic shift. Wait, I'm doing cyclic shift. Okay, 5 can be here, but if we do cyclic shift here, then it is not possible. This is true. Cyclic shift must be like, okay, we can do cyclic shift here. We can make this 1, 2, and then doing cyclic shift here will definitely we need 3 here and 4 here. So also swap 3 for, then it must be possible. Okay. I am saying that I can do cyclic shift here, so I will do cyclic shift here to make it 1, 2. Then I can do cyclic shift in these 3 node, so this will come here probably. So 1, 2, or this can come, or maybe 1, 2 and 3 and 4. So 9 is 4, 9 is 4, 8 is 3, then it is possible. I think I'm correct, right? I'm correct. Let's go to problem Z. Era and deadlines. So Euro has n homeworks. People are fast today, very fast. Last problem. I hope I can solve that. Problem Z. Euro has n homeworks assignments. For each assignment, its weight is AI is known. Its weight AI is known. The number of course. Of course, points Euro will receive if he completes it. Euro wants to choose a subset of assignment to maximize the total number of points. However, he has one problem. Some assignments are too time consuming. If Euro works on 2 assignments at position ij, there must be enough other assignments between them. Otherwise, he will get distracted and fail to complete them. Formally, for any 2 chosen assignments within indices ij, the following condition must hold. I minus j is greater than equal max of this. Find the maximum total weights you can obtain by choosing a subset of assignments satisfying this condition. Subset of assignments to for any 2 chosen assignments with indices ij, max of ai aj must be greater or equal less than the length or the difference between their indices. So max of them must be greater less than their indices. Find the maximum total weights you can obtain by choosing a subset of maximum total weight. Choosing a subset of assignments subset. Okay, now I'm getting it. So you can probably choose any one of them. No, like they must be. It's not as good. Now the answer is 2 for this test case. Yeah, it's like just choosing on assignments and nothing else. Yeah, it's just like choosing on assignments. Since they say the subset length can be 1, right? Problem G. So problem Z is kind of like that we are given an array of integers. We need to choose. We can choose a subset of the values integers in the array such that any two of them, such that for any two of them that this condition hold. Following condition must hold, that is max of a comma is a must be less than abs of c minus I. Maximum of them must be less than. Okay, so let's say c is always greater than I. So max of ai comma is a must be j minus I, right? If we consider az to be greater than ai, then we can choose elements in range 1 to z minus, then it's like a of z must be less than z minus I. So c of z less than c minus I, so a of c minus c less than I. Sandal. Recording is ongoing and I'm solving problems. The last problem remaining. আজকে সবাই ধুমধার একটা সব সলভ করতেছে। লাস্ট প্রবলেম 500 জন মাইরা দিছে। ভাই সময় নাই তো, তাড়াতাড়ি মাইরা দেন যায়। So you can choose elements in this range if we consider a z to be greater than ai. is something like if we just choose a increasing sequence. I'm very confused how to do the problem. See, who did that? They all are thinking problems. Let's keep working. So we can either like fix aj to be greater than ai. In such a case, then we know which are the elements we can pair with aj. Okay, I have an idea. Like, we can fix m such that we will find the maximum size of this subset with values less than or equal to m. So I think it is easy. So in that case, all the values or all the elements will be, the difference between them must be in range. Sorry, like the difference must be greater than m, right? The difference must be greater than m. Then the difference must be greater than m. So let's just take the inputs. This is our m, okay? So we'll try to find answer for this. So let's keep answer variable. Later we will output this answer. Now, how to find this? I feel like the way I am thinking is correct. Like if we fix the maximum value, and when the maximum value is greater, then our search space is very restricted. So it's like 0 1 0 1 0 1, right? 0 1 1 0 0 1 1 0 0 this kinds of values. So it's like we are given a binary string and we need to remove the minimum number of ones such that the difference between all ons, it's like we are given a binary string and we need to remove minimum number of ones such that the differences between any ones is less than m, but it is wrong. Because there can be minimum elements than m such that their differences can be less than m, right? Okay, then how can we think of it? How can we think of it? Difference must be greater than this. I think I need to change my approach, probably. I think it's like a DP problem. Like the values which are greater than n is like pointless, right? And all the values which are 0 are also pointless because we do not need to take them at all. And the values which are greater than n are basically n minus 1, because the difference between n and 1 is n minus 1. So we will consider the values in range 1 to n minus 2, right? Difference must be smaller than that. So all the values which are greater than n minus 2 or equal to 0 are unnecessary. Since now the values are basically also, let's do this thing. These values are necessary. Okay. Now if we take the value n minus 1, then there can be at most 2 elements in that subset. So it's like n minus n plus 1 plus 1. So it's like n minus max value plus 1. Is that true? No. No. And also the elements needs to be in the border. Okay, if we choose the maximum element to be n minus 2, n minus 2, not n minus 1. Now if n minus 3, then if you consider the value in the border, then we can take another value which is probably at position 2, and it is in position n minus 3. They cannot take any other value as well. So it's definitely no, not necessarily. It's definitely better. Like we at the same time we need to increase the sum at the end of the day. So for example, we choose 2. Here, or we choose 4 here maybe. Which is better? Maybe like 4 here, because the difference is 1, 2, 3, 4, 5. 4 here. This is better. This is better, right? Better to choose 2 and 4 instead. 2 and 2. Is it? No, not always, because maybe you can choose no, it is, I think. Yeah, it's not always, I think, because if there is a 3, if there is a 3 in the right side of 4, which is valid for 2, not for 4, then we can have the sum 7 instead 6. So we basically cannot greedily choose, I think. Is this like a stack problem? Is this like a stack problem? DP with a stack optimization? Alright, for this stepping. Or maybe segment tree. Wait. If we start with the minimum values, yeah, it's segment tree DP. Got it, bro. Segment tree info. So we'll just find the range. It's just like val. So val is initially 0, I guess. 0, right? Yeah, 0. Say assignment operations, the value will be the 6, and this will be the max of air val from beard. So f of I dot put like this. If only if like now which index to choose first? I think we can go from consecutive way, like we can just go like this, id of f of I, right? The value is I. The value is from 1 to n minus 1. So what are the ranges? Left. So not like this. So let's start from 1. So let's start from D. Okay. This will be dp dot segmentary dp, right? What is the name of the segmentary? ST. Okay. We know the ranges, like from where query from 0 to n minus 1 dot val. Isn't the maximum value in range, right? Max. Okay. Now left dot second will be id minus I, right dot first will be id plus I. So car is basically dp dot query left dot first comma left dot. dp dot update id comma id from max of left val comma right. Dot val. What? It's point update, not range. plus a of I id plus giving wrong answer. I think it is wrong. I just need to do this. So if id minus I is greater than or equal to 0, then dp dot update I comma dp dot query 0 comma id minus I plus a of I. This is basically a of I. So dp dot update I comma left plus fi. How this is 7? Wait, bro. It's not 4. I minus a of I. It's more like minus 1. Six to 8, 9 is minus 1. Yeah. Now it's okay. We don't need this. Why it's segmentary? Because we can update, we can do point update and range max query. Define long, right? Yeah. Wrong on test 2. No way. Yeah, this is wrong. Because we cannot go for all the values. case we are going to the left, so and this will be dp2.range from 0 to basically 1 to AFI. In this range, oh shit. Yeah, we do not need 2 dB. Let's go through the order. Okay, we'll basically do this in order from minimum to max. If AFI A of Z, then return AFI less than A of Z. Again, wrong on test 2. Facing a problem. So I can visualize what is happening inside, like why it is giving me wrong answer, right? I cannot understand, but how to fix that?